If you remember the gRPC video, we had to generate some Python and JavaScript code to make the whole thing work. That process was kind of tedious and the commands are pretty complicated. In this video, we'll make a tool to abstract that whole process where you'll only need to upload a proto file and specify the languages you want, and then get a URL back where you can just download the automatically generated code. Along the way, we'll learn about some really cool built-in Python modules, including Flask and argparse, as well as AWS and Docker. Before we build this, I wanted to quickly demonstrate the working product. So here's a proto file that I've defined. It has an RPC and 2 protocol buffers inside of it. We're going to make use of this to auto-generate some code with this tool. I wrote it in Python, and by specifying the path to a proto file and language type, I'll get a response back with the generated file URLs. Opening up one of these, we'll see that it gets downloaded, and then if I open it quickly in Vim, you see that the code was generated correctly from this proto file. As mentioned before, this tool moves the code generation step into the cloud, and the generated files are uploaded to an Amazon S3 bucket, meaning that you can share the URLs to these generated files with anybody. Let's quickly go over the architecture for this tool before building it. We'll make this tool with Python and split the code across a client and server. The client code runs locally on your laptop or computer and sends the proto file over to the server, which is running within a Docker container on Amazon EC2. The server will receive this proto file along with the languages we specified, generate the code, and then upload the generated files to S3. After uploading it, it will respond to the client with the URLs. To build the client side of this tool, I'm thinking it'll be easier to understand if we break it down into steps. First, we'll start with checking if the supplied proto path exists. Then we'll see if the specified languages are supported. And then after, we'll go ahead and ping the server to see if it's up. If it's up, we'll send the proto file. And then finally, we'll wait on the server to respond with the URLs and then show them to the user. Cool. Open a folder in your favorite text editor, and let's define a file called proto-gen-cli, and this is going to hold all of our client code. Now I'm going to import a module called argparse, which is a really cool built-in module for Python, and it allows us to take arguments from the command line like you saw in the demo. I'm going to declare a argument parser object real quick, and then we're going to add 2 arguments, which is first going to be the proto file, or the path to the proto. Let me fix that and add quotes. And you can look up online a little bit more into the documentation, but basically we're just going to specify we need 1 argument and then supply a help string just to let the user know what this argument is and that it's a path to the proto file which we are going to generate code from. Cool, now that that's done, we're going to add our second argument, which is going to be for language, and dash in front, which makes it a flag. And we'll just say that the argument it takes is 1 or more, and then supplying a really quick help string for this argument, we'll just say the language is, conditional S to generate proto code 4. Nice. Now that that's done, let's just quickly play around with this parser object. So I'm going to assign the parser args function to a variable called args, and we'll just print it out. So if I go ahead in the terminal and I try to run the Python file without supplying any arguments, argparse automatically prints out this response here saying, hey, you need to specify protopath or language. And then if I do -h after, you can see that it matches the help string. So this is super cool. All built-in stuff. We didn't really have to do much work for that. Now let's go ahead and use it like we were supposed to. So I'll just put a first argument for protopath, then I'll do -s language and say JavaScript. You can see that it prints out these arguments automatically. So protopath is hello and the language is JS. Let's format these this print statement a little better. So first I'll just print out protopath, and we'll do the same for the languages down below just to better visualize that we're getting this data from the command line. Pretty cool. All right, so there you go. You see protopath, it's an array of strings, along with language, also an array of strings. So if I take the first element of protopath, you'll see that now it's just the element, the string itself. And then let me supply 1 more argument for language. You see that it automatically parses it like an array. Very, very cool. All right, now with that being done, I want to throw all of our logic for the client into a class, and I'll just call it proto generator client. In here, go ahead and make a constructor. And for now, we just won't take anything because we're just formatting the file a little bit. So put a pass statement in there. Cool. I'll try to keep the file indented to 4, just to follow the convention for PEP8 syntax. And then down here, I'm just going to do a conditional just to check that, you know, the script we're running is directly from the command line. That's what the name equals main is. So now I'll assign an object to our client class. Boom. Nice. And then let's change the constructor to take 2 arguments. So it'll just be both arguments that we supply from the command line. All right, with that done, obviously I have to change it on line 24. So first I'll send in args, you know, protopath 0, just like how we printed it out. And then we'll just send in the array of languages. Cool. And in the constructor, I'm just going to print these out real quick, just to make sure that things are working as they should. Yeah, so we're going to throw everything we need into this class to handle uploading the proto file to the server, getting the response back, making sure the client gave a valid path and also specified valid language types. So you can see I'm just rerunning the command with, you know, as we're supposed to use it, and the class got it, which is very cool. Okay, with that being said, I'm going to assign some class variables now so that we can, you know, keep track of these arguments. But before doing that, let's just import OS, because we'll make use of OS to check if the path is correct. Yeah, and right here we'll also do the full proto path. You can do os.getCWD within this os.pathJoin. So taking a look real quick, this will work on any OS, so Windows and Linux or Mac. So I'll just do os path join. We'll take the current working directory and then also the supplied proto path. So let me go ahead and rerun this down in the terminal, and you'll see that we have the full path. Assuming the file was, you know, called path to something, you can see that it goes in my, you know, home user directory, then in the folder we created, and then just the proto file right there. So we'll use that to open up the file, read the bytes, and then upload it to the server. Yeah, now I'm going to create some class variables just to assign, and then we can use across, you know, the different class methods. So we'll take the proto path, just the name of the file, and then we'll also just take the full path. This will be good, so just in case the file can't be found, we'll just say, hey, we couldn't find your file. Cool, just grab language types, real simple. And then now with the constructor done, I'm going to go ahead and define our first helper method, which will be what you call from the main script. It'll just be handle proto generation, and that should just do the whole thing. So it'll check the path, languages, upload, and respond. So in here, just so that we keep track of what we're doing, we're going to go ahead and put some comments down. So first we'll just, you know, let it know our workflow, just like we saw in that quick slide with the steps. And we'll replace these comments with code as we go, but it's really just so that we can keep track of what we're done and what we still have left. All right, so this function right here is just going to check the file path. As mentioned before, that's the first thing we should do. So it'll just use the self.fullProtoPath and make sure it works properly. I'll just paste the comment right there just so it's a little more understandable. All right, cool. And the next one is we're also going to check the language types. Want to make sure that we support the languages that are supplied. For this tutorial, we'll just do JavaScript and Python, but you can obviously expand it if you want, but this is just a function that will check whatever you already support. All right, so now hopping back into the check file path, I'm going to go ahead and use the OS module, and you can just do os.path.isFile, and then I'm just going to pass in the full proto path. And if it isn't, then we'll do something about that. We'll just say something to the user saying like, hey, that file doesn't exist. So we're saying the path, use an F string. So by putting F in front, and then you can use brackets to insert variables. We'll say the path, self proto path cannot be resolved. Keep in mind, proto path won't be the full path. It'll just be like whatever the user supplied as an argument. And we'll test this out in a moment. But let me just format this a little bit better. So we'll check if the file exists with this variable. Set it to true or false depending on the result, and then we'll just return it. That way we can check in the handle proto generation function if the check was, successful or not. Because if it wasn't, then we'll just stop. No need to continue. All right, cool. And now for the language types, I'm going to go ahead up top and just define another class variable, but it'll just be a dictionary. I call it language map, but it's the same thing. So I'll just map strings to booleans where, JS, Python's true. Say we wanted to do it for like C++, then I would just put another one right there, mapping it to true. But for now, like I said, we're just going to support 2 languages, the ones that we used in the previous tutorial. And now we're just going to iterate over the keys. So, for each language not the keys, we're going to iterate over whatever the user supplied. So remember, language types is from argparse. And then we're going to go ahead and just print checking this language. And if it's not in self.language map, that means that they supplied an invalid language. For now, I'll just put pass, but we definitely want to comment out our workflow here, saying, hey, we're going to say that the languages you supplied were bad. We'll print what we support for the time being. I'm going to define a new helper method that we'll call on from check language types. And this is just going to print the string that we want to return to the user saying, hey, your language is invalid. And that, there's something wrong. But before we do that, let's go ahead and just, handle the proto generation. Fill that out a little bit with our 2 functions we've already created. So we'll check file path, and then we'll go ahead and check the language types. Cool. So running this now, if we give an invalid path, we should see, let's take a quick look. Oh, of course, I forgot to put handle proto generation down there. All right, let's get it. Cool. You can see path to something could not be resolved, and then it checked the 2 language types. Obviously, we don't do anything if the language is invalid yet, right? There's just a pass statement. So now let's actually define this print supported languages function. So just type it out. Remember, need that self parameter, and then in here we'll definitely need to iterate over our dictionary that we defined at the top of the class, just saying like, hey, come on, do better. So first thing I'll do is we're going to use the very helpful string.join function with a comma, and this variable here, supported types, is just going to take the keys from the supported dictionary or like language map up top. And we're using a little list comprehension here. So basically what's happening is for every element in the self.language types, we're going to just print it out and separate each value with a comma. So we'll say supported language types are, and then we'll just print supported types. Okay, and then now we'll just call on it from the check language types real quick. Yeah, just indent that by 4. Let me quickly change my setting. Yeah, there you go. That way I'll always indent by 4. So we'll replace this pass with just saying self.print supported language types. All right, let's do it. Oh yeah, I need to give something that's not there. Okay, meme. What? Oh, I messed up. Sorry, it's a language map on line 39. Sorry about that. Cool, there you go. Now it's working as such. So you can see that when I gave meme, it was like saying, hey man, we only support JavaScript and Python. Get it together. All right, cool. Let's add a parameter. So what we could also do is, send in the language that was invalid. So right here, I'm adding a parameter called unsupported type, and then I think we'll print something right before we'll say like, sorry, couldn't do it. So we'll just say unsupported type is not a supported language. Cool. So this will help the user a little bit more. Just like saying, hey, why did I not give my file URLs? Well, I don't know. Meme isn't a language, is it? Nice. And then we'll just return false if it's invalid. So you see that right there? Sorry, meme is not a supported language type. And then it just prints out what we do support below. Nice. So we have file checking. We have language checking. Let's put this inside of a like if statement, so that we can just check back to back. And if either of these are not returning true, then we'll just return and just give up. We'll be like, all right, I don't want to go on and try to ping the server or any of that. Yeah, you see, so it does lazy evaluation right here. So it is just first checking the file path, and if the file path isn't valid, it doesn't even bother trying the languages. Let me create a test file. Did ls, see there's test now. So if I supply test, it should, go on to the next part. Yeah, there you go. Very nice. So now if I do it all valid, it works as such. Cool. Now that the client has some very basic functionality, let's switch gears and start working on our server. Just like before, let's go ahead and break down the server logic into steps. So first thing is we'll create a directory, move a given proto file into that directory, generate the appropriate language code, upload to S3, and grab those URLs and respond to the client. Nice. Should be pretty straightforward. Let's go even further with another visual for how this server is going to go about generating the code. So say the server is going to have this folder, and it'll receive a proto file from the client, and what it'll do is it'll save that proto file in the folder, and then depending on what the user specifies, we'll go ahead and generate the JavaScript or the Python code within that folder, and after that's done, then we'll upload it to S3. Really simple. Now, being that it's a server, it could get multiple requests at once. And I want to talk about how we're going to go about naming our folders that we create to store these proto files in. So example 1, let's just say that we have a temp folder, and whenever we get a proto file, we'll throw it in there and we'll do the generation step that we just talked about. But problem is, what if we get 2 requests at the same time? That means both go into temp, and then we would get a collision where we'd have, different generated files sitting in there, and who knows what's going to happen. Uploading could be an issue. A better way I thought of is say that we have a folder with a completely random name. For every single proto file that gets saved, it goes into this randomly named folder. And if the second request comes at the same time, guess what? It's going to go to a different folder name. As you can see, they're slightly different. They're both randomly named using UUID. All right, now let's take these 5 steps for the server logic and turn them into Python code. All right, back in our folder, I'm going to create a folder within this folder called EC2, as obviously this is going to be running on EC2, and I'm going to declare just create a file called server.py. All right, so first import is going to be from Flask. You should have Flask installed. You can just do pip install Flask. And then I'm going to define a variable called API. And then right here is where you can define these endpoints. I did a tutorial on like simple JavaScript APIs, but this isn't much different. It's just in Python now. I'm going to make a route just for the slash route, and it'll just accept a GET request. And then below is a function you define where you want to handle the request. So like if it gets a get HTTP GET request on this slash route, then it's going to call handle health check and go about doing something. And right here, I left a comment. We're just going to return something to the client to say we're alive. So this is the client's going to check that the server's up before it tries sending the file over. Otherwise, there'd be no point, right? So importing JSONify at the top, let's just return JSONify with a success parameter equal to true. So it's pretty straightforward. That's the simplest route in the whole world. All right, now we're going to do a very simple if statement, just checking if name is main. We're running this folder directly. And if it is, we'll run the API and bind it to localhost. That's what that 0 IP address is. And then threaded is true. Because if you didn't make it threaded, then it could only handle 1 request at a time. It's kind of goofy. Yeah, I'll just leave a comment here just to say to run the server. We also need a special command that it will allow us to, like if we save, the code will automatically refresh. We don't have to rerun the Python file. So you do flask app equals, path to the server file. We'll make the environment development, and then at the end you do flask run. And then we could just leave this running for the rest of the time, opening it on, localhost 5000. It goes to that slash route and we get a successful JSON response. Cool. All right, now we'll go back to our client and then let's just, define this health check function. It's pretty straightforward. So this is like another, kind of like check before we go about doing anything, like uploading files. So in a try catch, I'll define that. But first, let's import requests. This is another built-in Python module that allows us to send HTTP requests. So really, really simple right here. Let me define one more class variable. I'll just call it server URL. And for now, this will just be, 127.0.0.1, port 5000. We'll change this later to the EC2 IP address when we get there. But it's good to declare in a variable up top. So we'll just send a GET request to the server URL. And then we're going to accept an exception because it will throw an exception if the server is down. So we want to handle that instead of throwing like an error to the user. And that's going to be the connection error. I'm not sure why that's red. Okay, it went away. Cool. Just had to save. And then down here, we'll just print saying, hey, the server's down. Again, it's an F string, so we'll be able to insert, variables into it. So we'll say the server at blah, blah, blah is down. Keep in mind that URL up top will change to the EC2 IP address. So we could just, all we have to do is change that one line up top and then the thing will work. Now, we can do multi-line if statements. So using those slashes right there, we can do or and then backslash. And then we'll also down here just check one more thing, the health of the server, make sure it's up. Let's go ahead and run this. Obviously, see if you don't give anything, argparse is going to get mad. So we'll do test language JS. Nothing printed. Okay, that's fine. Let's print it. Ooh, that's weird. I killed the server, but nothing happened. It's kind of strange. Let's look around and see what the problem is. So I definitely should return true if the server's up instead of nothing. Let's go up here and take a look. Okay, let's try that server URL. I think you need HTTP in front. That was my mistake. All right, and then looking through this file, I noticed that in the check language types, I needed to also return true if the languages were valid, as I wasn't really returning anything to begin with. So let me kill the server again. Go back. Boom. There we go. Now let me go ahead and bring this server back up, and let's make sure that it doesn't print anything bad when we go back and run it. So let's rerun this. Okay, cool. As it should. Very nice. So we've successfully added the health check, and then now let's go about adding this upload. Before we go about doing that, I added a really quick proto file. This just is for printing pages from a website to a Python server. Very simple. So now back in our client, let's go and define a generate API URL. So it'll pretty much just be the server URL, and then we'll just add / generate. And keep in mind, this is in the client. We're just adding another class variable up top. Nice. And then now let's go back in our server.py and EC2 folder. Add another route / generate. And then the methods we'll take this time is just a post request. And very similar to the pattern above, we define a function below. This one will just say generate gRPC code. And then right here, we'll go ahead and just return JSONify success true. Obviously, we'll build this out, but let's just go ahead and, have a placeholder there for a second. All right, now returning to our client, I'm going to define another method called call generate API. It won't take any parameters. And all we're going to do here is we're going to do another try catch. Let me just steal this from the other function. I don't feel like rewriting it. So, okay, cool. I'll rename healthy to something. Let's do result. All right, nice. Now we can do a really cool trick with sending over these parameters. So remember, we need to send over the file and language types. So I'm going to declare a variable called params. And we're going to cast this result to a dictionary. So it's just going to be language, true, capital T, of course, for language in, and then self.language types. So I'll print out params below just so it makes a little more sense. It's basically just generating key value pairs automatically. So after our if, all of our checks, we'll just call generate API. Cool. Let me just show you real quick how this works. It's pretty cool. I like Python for this. So We'll give the proto path language, put JS. Notice the print statement on line 68 automatically generates this like key value pair. It's pretty cool. And then that's what we'll do to send it over to the server. Anyway, so now that that's out the way, let's go ahead and open our full proto path to read the bytes. And I'll just open it as this variable called f. And, after we open this file, we're going to use the requests module again. We'll send a post instead of .get, .post. We'll do it to generate API URL. And then following that pep8 style, files, very, very simple. You just do the proto path. It's a key value pair. It's like a dictionary. So you do the proto path to the file f, and then also the params, which is going to be the language types. So we're going to send all that over to the server, and also going to just redefine response. Makes more sense to do that instead of result. All right, nice. So let's go ahead and rerun this. Cool. And if we go back to the server, you see how it says post generate and then Python is true? That's how we use those key value pairs. It's pretty lit. Now back in our generate gRPC code function, let's go ahead and handle this stuff getting sent over. Now, what you can do here to extract the file name, because it'll be separated by slashes, you can pretty much just take the files, the first key that comes in, and then we will just get the first element, obviously, since there's only going to be one key value pair. And let me just print out file name and the request.args just so that makes a little more sense. Yeah, I need to import a request at the top. So let's go ahead and rerun this, go back to the server, and you can see right there that it got printed out the file name, and then the args is in that dictionary, py mapped to true. All right, very cool. We're really building this bridge out here. And to handle most of the logic, just like the client in the server side, I'm going to create another class. And I'll just call it protofilegenerator.py. We'll import two things we need. OS. We're also going to need UUID for that random folder name generation that we talked about earlier in that diagram. I'm going to import a submodule called path from OS. We used os.path last time, but this time, yeah, why not? We'll just switch it up on them. Let me change this back to 4. I really should just use 4 when I write Python. It's default to 2 for when I do JavaScript stuff. But anyway, so quick constructor. This is going to take the proto file and the language types. And the proto file is going to be like an object itself from the request module. So we'll just assign self.protofile to protofile. Class variables to their parameters in the constructor. Pretty simple class stuff. And then we're also going to do the same exact thing, just like the client. We're going to have this single helper method that we'll call on, and it'll do everything. So it'll generate the code, create the folder, upload, and respond with some links. I'm going to leave some comments here just to better, keep track of all the things we have to do, just like we did on the client side. Very, very simple. So first, obviously, create that directory. We'll save the file. Then we'll generate the code, upload to S3. We'll delete the directory just so we don't have a bunch of clutter on the server side. Make sure we clean up, and then we'll respond to the client with the S3 files. Cool. So now to handle the first thing we commented out, I'm just going to create the UUID directory in this function. One more thing we should do is we definitely should keep track of the directory name when we create an object. So it'll be just string UUID. You can use the UUID4 function, so this will return some random string every time. So it'd be UUID.UUID4. And then we're also going to keep track of where we are before we cd into that directory. It's just so that we can, go in our terminal and then also cd out, change directory out, just like I left that comment right there. And then that's how we'll also be able to clean up at the end and delete directories that we don't care about. All right, nice. So inside the create UUID directory, we can do os.make directory, mkdir, and then we'll cd in there with the chdir. And below that, we're also going to, just like how we create things, we also should clean up. And this is really, really simple. So we'll just change directory back to our original, which is backup one. And then we're also going to import shutil. This is going to allow us to delete a directory using rmtree, self.uuid directory, and ignoring the errors because we don't want to get hung up on that. That would suck. The user would just wait and not know what's going on. All right. So let's also import time real quick. So back in our helper function, we'll use the time module. We'll sleep for 5 seconds after we create the directory, and then after we'll remove it. All right. Now back in our server file, let's go ahead and import our class that we generated from the proto file generator. You can see that you can just do it like that on line 5. After we import it, let's go ahead and just define an object. Sorry, let me move that up into the generate function. So we'll just do, before we define the object, let me grab the files from request actually. So just like that. And then we'll use it in the constructor. So on line 21, this is where we're actually defining the object. Proto file generator, we're sending in the proto file. And then the args, which is just going to be like a map. Nice. So you can see that we're getting the request. And now we just need to do the handle proto generation. Let's go ahead and do it. But before we actually do that, let's go ahead and add one more function. Let's go back here. After we create the UUID directory, why don't we save the proto file in there? So, takes a single or no parameter really, and then self.protofile.save, path.join, and then we'll just do os.getcwd. And this is assuming we're already in the UUID directory. And then the second parameter is just the file name that we're going to save it to. So you check this out. After we create the UUID directory, before we wait 5 seconds, we'll save the proto file. And then wait 5 seconds and we'll remove it. So now let's go ahead and do it. Boom. Look at that. And as quickly as it came, it's gone. So after 5 seconds, it goes away. Anyway, one more function we should add here, obviously, is going to generate code based on the languages that the user sent. I'm going to put a comma here. So for each language the client sends, we're definitely going to want to call a separate function. So we'll, handle, generate node files, and then also generate Python files. So these are our 2 helper functions we will conditionally call on. Obviously, if you want to support something else, like I mentioned before, you could just add another function. Pretty simple. So we have generate node files, and then this other one, let me rename it. Generate, name this one to generate Python files. So change the function name and say time to generate Python. Cool. Whoa, there it is. Don't know why I couldn't spell right there. All right, now before we go, or basically just to determine what we need, we're going to define another dictionary up top. It's just going to be a string mapped to a function. So right here, it'll just be like language type function. So if it's JS, if we get JS from the client, then we'll call on generate node files. If it's Python, you guessed it, we'll call self-generate Python files. Pretty cool. Now, I realized that, hey, you can't do that because you're using self outside of a function that, takes self as a parameter. So I quickly moved it into the constructor. I did self.generator dict. And now let's go down here and we will iterate over the language types sent from the client. So for each language type, obviously it's a dictionary, so you gotta do keys. So it'll be like JS or PY, and then we'll check if the given language type's in the dictionary. If it is, then we'll go ahead and call on it. You see how I accessed the key and then I did the function called parentheses. Pretty cool. That keeps things very dynamic. So if you want to add another function, you just modify the dictionary and also add a class method. Nice. And then we'll move these comments around because we still need to do S3 logic. That'll come a little later. But for now, you can see that when I supply Python in the server, it says time to generate Python. Let me do it with a different argument. So if I do Python JS, go ahead, boom, very dynamic, super cool. All right, back in the server class, I've pasted the commands that we're going to use to generate Python and Node. Now don't freak out, they're in the description. So if you check the description, there's a link to these commands so that you can paste them too. Honestly, don't worry about this. Like, there's really no need to type this out. The whole point of this project is to abstract this process anyway. So we're going to use os.system. I'm going to pass in an f string. Paste this in there. And we're also going to need that last line. And then instead of your proto file here, you're going to want to replace that with, the actual path to your proto. I'll move the print functions a little bit. Just format both functions before we go about, doing everything. Let me indent it. And then, after we should be good to go. We'll just call on generate node, generate Python, and it'll work without us having to do anything besides just calling the server, which is pretty cool. So we'll just pass in self proto file name. This is just going to do the same exact thing right here. Nice. Let's go ahead and test that out. All right, so you can see I run the file. Oh, I said JS and Python. Why did it only print Python? That's weird. Let's take a look. Let me add 15 seconds first, just so we have some more breathing room. Okay, cool. Those got printed out, and those look very valid. Let's see what happened. Why did this not work? Go to the server logs. Okay, we got some kind of error here. Oh, I know why. It just has to. It's with my string. See right here. Again, don't copy and don't write this out. It's going to be in the description. So if you want to follow along, just paste that for your helper methods. All right, now rerunning this function, we can see that looking in this random directory, we got the JS and the Python files. Very cool. Keep in mind that this is being done locally, so we're obviously running these tools within our own terminal. If you don't have these tools installed in your computer right now, that's totally fine. In the next video, we're going to show how we can throw this into a Docker container, and that you don't actually need to install the tools on your computer per se, but instead it'll all go into this Docker container that you create, which is super cool. All right, I'll see you in the next one.